Hey there, it's Dina from IDon'tGetItTutoring.com. In this video, I will be going over the domain and range of a graph. Let's get started. So, domain and range are used to describe the points in a graph, and by looking at the domain and range, you kind of get a good sense of what the graph might look like or to what extent it goes to. So, let's start with domain. Domain has a lot of meanings to it as a word, but in a mathematical sense, domain is all the x values which make the equation true. These are all the x values which are also on the graph. So, for example, if we had x plus 2 equals 3, the only x value in the domain that would make this possible would be the x value of 1. So that would be our domain for this. But let's say we had x plus 2 has to be greater than 5, let's say. We would have to find all the values that make this true. So, to solve that, we cancel out 2 by subtracting it on both sides. 2 minus 2 is 0, right? So x has to be greater than 3. So our domain would be all the values greater than 3. And that covers all the x values which make the equation true. Meaning it has to make it true and it has to stay within a certain interval. For this example, the interval was greater than 5. Okay, but let's talk about a graph too. Now, let's say we had a graph on the coordinate plane and we had something like this. And let's say this point, well, make this a little better. Okay. Ooh, still not. Okay, wait. A little more like it. Okay, this was its highest point right here. And let's say the coordinates of this is like x. X is 2 and y is 10. And then the point over here, let's say x is 15 and y is 3. Okay, so this is the highest point. Oops. And this is the lowest point. Meaning we have the greatest y over here since it's our highest point. And since this is our point that's the most out this way, that means this gives us our greatest x value. So our greatest y value, like we said, is 10, right here. And our greatest x value is 15. Meaning it doesn't go past the y of 10, and it doesn't go past the y of an x of 15. Now, it also has limits on how low it can go, meaning for the y's in this case. The highest it could go is 10, but the lowest it can go is 3. So y has to be less than 10, but it has to be greater than 3. Y has to be between 10 and 3. And in this case, since these coordinates are closed, that means it's inclusive. Y has to be between 3 and 10 inclusive, meaning that it can be 3, it could be 10, and it could be any number between 3 and 10, but it can't be 11 or 2. Now, we know, okay, we already did Y. I don't want it to get too messy, this graph. Try to clean it up a little. Okay. Now, we know X, the highest it could go is 15. What's the lowest that it could go? 2. So, X has to be less than 15, but it has to be greater than 2. And it's also inclusive because 2 and 15 are in the graph. So this is our domain right here. I know I did Y, I'm sorry, but giving you a little head start on finding the range. So our domain on this graph would be 2 to 15, inclusive. And you guessed it, if you couldn't already tell, the range all the Y values that make the equation true or, like we said in this definition, are on the graph. So for example, if we had 2 plus 3 equals Y, the only value that Y could be is 5 because 2 and 3 only make 5. And if we wanted 2 plus 3 is greater than Y, Y has to be less than 5. That would be our range here. And on a graph, well, let me use the graph example that we did earlier. This would be our range for this graph because it's the extent of Y. It's as much as Y goes up, the farthest it goes, and it's its maximum and minimum in the Y values. So, make it a little simpler. Range all Y values. Domain all X values. It's as easy as that. Now, there is some notation you must know when writing out the domain and range, specifically in intervals, because let me take this example over here. Y is between 3 and 10 inclusive, and X is between 2 and 15 inclusive. Okay, so if you were to write this as an answer, it would be completely fine. This is correct. However, if the problem, the question, specifies that it wants your answer in interval notation, you need to write it this specific way. So interval notation looks like this. I am going to explain exactly what this is. It's just an easier way to write all of this out if you don't want to be writing symbols and numbers. Just an easier way to do it, but it means the same exact thing. So in interval notation, this is interval notation. When you write it in an interval like this is a bracket. This is inclusive. But when you see something like this, right? So this would be less than or equal to or greater than or equal to. It's more rigid. You use a bracket. Oh, actually I'll use brackets for bracket. And this is just less than or greater than. You use parentheses. This is not inclusive. This is when you use parentheses. There's always going to be your smallest x or y, and then your largest x or y. Every single time. In this example, we used the ones with the less than or equal to sign, which shows why I wrote it here with a bracket. Let's say this interval was more like this, then it would be 215 with parentheses. And if it was 2 is less than or equal to x, but x is less than 15, then you would do bracket 2, 15 parentheses. You just look at the sign, and then you know whether to put a bracket or a parentheses in your notation. Usually, in your notation, you're going to use it most for graphs, but then again, if you're solving inequalities, you also might have to write your final answer as this as well, so it's always good to know. In this video, to sum up, I went over domain, range, what they are, their definitions, and how to write them in interval notation. Thank you so much for watching this video, and I hope you found it helpful. Bye!